It begins with silence, the kind of silence that does not simply lack sound, but absorbs it, bends it inward, swallows the echoes of the stars themselves. Across the vast gulf between suns, something glides. It does not shimmer, nor blaze, nor announce its coming with a comet's tail of light. It is a shadow crossing deeper shadows, a flicker barely distinguishable from the void it travels through. They will call it 3I Atlas, but for now it has no name, only presence. A faint ember adrift between the stars. In the cold arithmetic of interstellar space, every degree of heat is sacred. Yet this traveler carries warmth, not reflected sunlight, not the afterglow of a dying trajectory, but something stranger, a low, steady thermal signature, pulsing with a rhythm almost biological. Instruments will later trace its frequency and find an order to the chaos, a modulation that seems deliberate, as if the object itself is breathing. For billions of years, the solar system has been a closed garden. Everything we've known, planets, asteroids, comets born of the same cosmic dust, locked within the same gravitational family. And then, once in a human lifetime, a messenger slips through that invisible border from the dark ocean beyond. Astronomers once whispered that such encounters would be rare beyond imagination. Yet, within a few short years, two have come. The first, Oumuamua, the cigar-shaped anomaly that challenged every model of motion and reflection. The second 3I Atlas, colder, quieter, but somehow even more unsettling. When its image first flickered across the data streams of observatories in 2019, few noticed. It was small, dim, and unassuming, a speck in the data noise. But as the algorithms stabilized and the filters cleared, the object's motion told another story. It was not bound by the Sunday. Its trajectory was open, eternal, a line cutting through our solar system as though through tissue. And it came not cold and dead like a drifting stone, but with heat. In that discovery, something ancient stirred in the human imagination, that primal fear and fascination with the unknown. We look up, we measure, we rationalize, but in the quiet between those acts lies a question we've never truly been able to silence. What if something looks back? 3I Atlas was never meant to be seen. Its passage was supposed to be silent, invisible, unrecorded. But the instruments we've built, the eyes of Earth, now stretched into the heavens, caught a whisper of its journey. And that whisper revealed the unthinkable. Somewhere inside that lonely shard of darkness, something was alive. Not alive in the way we define life, not with lungs or cells or a heartbeat, but with warmth, purpose, a pattern of energy that did not belong to the random. It pulsed as though it remembered something. And so began the slow unraveling, not of the object, but of us. Because when the universe sends a messenger, the true revelation lies not in what it brings, but in how we choose to see it. It was early April 2019 when the sky blinked. Somewhere above the Hawaiian archipelago, where volcanic silhouettes guard the Pacific like ancient sentinels, a network of telescopes swept the night for dangerous wanderers, asteroids that might one day fall toward Earth. Their name was Atlas, Asteroid Terrestrial, Impact Last Alert System, a sentinel of stone and silicon, scanning the heavens every night for signs of celestial intrusion. On one of those nights, the system caught a glimmer that didn't belong. At first, it was dismissed a flicker, a sensor echo, a passing satellite reflection. The automated filters marked it and moved on. But as the data rolled in over the following nights, the same faint streak reappeared, crossing the same coordinates, each time with a motion that didn't align with the solar system's geometry. In the control room, the astronomers leaned in closer. Among them, a quiet man named Larry Deneau, who'd spent decades parsing the patterns of rocks and light, noticed something unsettling in the data. The object's velocity wasn't just high, it was impossible, over 30 kilometers per second faster than any body bound by the sun's gravity. When the team ran orbital calculations, the numbers unraveled the impossible truth. This visitor had not come from within. It was entering our neighborhood from interstellar space. The discovery spread quietly at first, a whisper among observatories, a coded alert between astrophysicists who had learned to be cautious with miracles. But beneath that restraint burned awe. Humanity had only ever seen one such interstellar object before, one-eye Oumuamua, the elongated enigma that had confounded every model 2 years earlier. That visitor had come and gone in silence, its origin and purpose lost beyond the reach of data. Now, another had arrived. They called it C-2019 Q4. Borisov at first a likely comet, icy and innocent. But deeper analysis suggested something else. The newly designated 3I Atlas was darker, more erratic, and warmer than any comet known. On September 28, a recheck of the data using higher resolution imaging confirmed the object's spectral fingerprints. It was no ordinary ice fragment. Its thermal profile didn't fit a comet's expected pattern. The warm glow seemed to emanate not from sunlight reflecting off dust, but from within. When astronomers at the European Southern Observatory pointed the very large telescope toward it, they saw a thin haze of gas that seemed to surge and fade, not continuously, but rhythmically, like breathing. Such patterns made no sense. Outgassing, the process by which comets release vapor under heat, should be chaotic. But 3I Atlas appeared to exhale in intervals. More observatories joined the vigil: Mauna Kea, Palomar, Cerro Paranal, and later the Hubble Space Telescope. Each contributed a pixel to the growing portrait of strangeness. Data streamed across continents, numbers, spectra, thermal curves, and slowly a question began to take shape in the silence between transmissions. Had we just witnessed a fragment of another solar system's debris, or something built? For centuries, humanity had dreamed of interstellar visitors. We had written them into myth, the chariots of gods, the messengers of doom, the wandering stars. But now, here was one caught in the act of crossing, real, tangible, measurable. And, unlike Oumuamua, this one didn't simply reflect the light of the sun. It generated its own faint warmth, measurable even as it drifted millions of kilometers away. Thermal images from Atlas's infrared band revealed blotches of heat that refused to fade as it turned, as though something inside was insulating or regulating temperature. That subtle persistence, a ghost of heat against the freezing canvas of interstellar space, was enough to unsettle even the most stoic physicists. Some dismissed it as instrument error, an artifact of calibration. Others compared it to the faint heat signatures seen in artificial satellites as they tumble localized and persistent, unlike the diffuse glow of natural bodies. But when the data was cross-checked with independent observatories, the warmth remained. A mystery had entered the solar system, not screaming through the skies, but whispering through wavelengths. It carried no message, no code, no trace of intention, only an anomaly, a flicker in the laws of thermodynamics. And yet, in that anomaly, something ancient stirred, the same wonder that once drove humans to paint constellations on cave walls, the same dread that made philosophers look upward and ask whether the universe could dream. That night, under the unblinking eyes of telescopes, humanity witnessed not a comet, but a question gliding silently across the stars. The motion of 3I Atlas was too clean, too deliberate. Its path sliced through the solar system like a surgical incision, precise, indifferent, unbound. Astronomers soon realized they were not watching an object orbiting the sun, but one simply passing through, answering to no gravitational tether. Its velocity told the story first. Calculations showed that even before entering the Sun's reach, 3 ATLAs had been traveling faster than 32 kilometers per second relative to the local standard of rest, the speed of the surrounding stars themselves. Such motion is not the product of orbital decay, not the byproduct of cosmic drift, but of expulsion. Something had thrown it outward, long ago, from another star's nursery. Its path was hyperbolic, the celestial equivalent of an open-ended road. Most comets draw elongated ellipses, curving gently around the Sun before returning to the outer dark. This one traced no curve. It came in, flared faintly, and kept going, a ghost cutting straight through our solar architecture, heading back toward the interstellar deep. Scientists modeled its vector backward, tracing the geometry of its entrance like detectives reconstructing a crime. The data pointed toward the constellation Cassiopeia, a region rich with stellar birth and death. Somewhere there, perhaps in a system that no longer exists, something had ejected 3I Atlas into the void. Yet it was not its trajectory alone that unsettled astronomers. It was its light. The way it dimmed and brightened with each rotation defied the simple rhythm of an irregular rock. There were harmonics in the reflection's secondary pulses that hinted at a complex, uneven surface, something layered. As telescopes refined their tracking, photometric curves began to emerge, graphs of its changing brightness as it spun. What should have been a chaotic scatter of data revealed instead an eerie regularity. Every 6 hours, a minor peak. Every 12, a major one. The ratio was almost musical. Some described it as a heartbeat. Others, less poetically, called it a nonlinear albedo modulation. But even they couldn't ignore the implication. The surface of 3I Atlas seemed to alternate between reflective and absorptive states. Some regions glinted sharply like metal. Others swallowed light entirely. In normal comets, these shifts correspond to outgassing jets of vapor that brighten certain spots temporarily. But the thermal data told a different story. The brightness peaks didn't align with solar exposure. They persisted even when those regions turned away from the sunday. Something inside was generating, or preserving, energy. By early 2020, the world's astronomical community had become quietly obsessed, not with the idea of life that would have been too sensational, but with the feeling of wrongness. In a universe that so often obeys its own precise mathematics, 3I Atlas seemed to hum a discordant note. The comparisons to Oumuamua became inevitable. That earlier interstellar traveler had also spun erratically, accelerating without visible propulsion, its shape narrowing to the point of absurdity. It had left physicists arguing whether it was a rock, a sheet of metal, or something in between. Now, 3I Atlas seemed to echo those same defiant traits, but colder, subtler, more deliberate, as if the first visitor had been a whisper and this one an answer. When scientists at the Max Planck Institute modeled its reflective pattern using synthetic light curves, they noted that no known composition could reproduce the data unless part of the object possessed an unusually high refractive index similar to certain carbon lattice materials or engineered composites. The suggestion was buried quietly in the paper's appendix, hidden among equations and caveats. Non-natural surface morphology cannot be ruled out. Those 6 words spread faster than any discovery notice. And yet, for all the speculation, the most astonishing detail remained its internal warmth. The Atlas survey's infrared readings had been confirmed by NEOWISE and corroborated by ESA's Gaia telemetry. The object's internal temperature was slightly higher than the theoretical maximum achievable by solar heating alone. It was as if it retained the memory of another star's fire or carried its own. As it drifted past the orbit of Mars, the object began to fade from most optical instruments. But even as its reflected light waned, its thermal signature persisted, like a ghost refusing to vanish. To most observers, this was an academic anomaly, a data point in a long spreadsheet of curiosities. But for those who had devoted their lives to cosmic mechanics, it was heresy. The solar system was supposed to be predictable, its physics immutable. Every rock, every atom, every orbit, an expression of cosmic law. And yet here was something that glided through that law as if it were optional. If its warmth was real, if its rhythmic rotation held structure, if its trajectory was the scar of ejection from another world, then 3I Atlas was not just a traveler, it was a witness. It had crossed the gulfs of interstellar night, carrying within it the residue of another dawn. And as it slipped silently through the reach of our sun, the instruments of humankind, our telescopes, our algorithms, our trembling curiosity turned toward it, seeking not just what it was, but what it might remember. The first anomaly to draw real alarm came not from the optical telescopes, but from the thermal archives. In late 2020, as the world's attention faltered amid earthbound turmoil, a quiet study from the European Space Agency circulated through the astrophysics community. It concerned 3I Atlas's heat, an emission pattern that refused to obey the arithmetic of sunlight. Every object in space radiates heat. Its temperature, in theory, is a simple equation, solar input balanced against emitted infrared. But 3I Atlas glowed where it should have been frozen. Its surface temperature, hovering around 70 Kelvin, was several degrees too high for its distance from the Sunday. A trivial difference perhaps, but in the cryogenic calculus of interstellar objects, those few degrees were a chasm. Even more disturbing was the pattern of that warmth. It wasn't diffuse, as if sunlight had gently baked a surface. It was patchy, clustered in elliptical zones that appeared, faded, and reappeared across its rotation. When NASA's NEOWISE satellite refined its thermal maps, the pattern seemed to pulse. Infrared readings captured a subtle oscillation, peaks and troughs of heat every 6 hours, perfectly synchronized with the object's rotational period. Something inside was cycling energy, as though it were breathing. In the control rooms of JPL and the European Southern Observatory, disbelief met protocol. The data was checked, recalibrated, and reprocessed through 3 independent instruments. The pattern remained. Instrument artifact, some said, dust contamination. Others pointed to sublimation gases venting from buried ices as they vaporize. But sublimation was random, chaotic, noisy. This was not. The heat came and went like a heartbeat. The team ran models of volatile composition, water, ammonia, methane, and still, the phase curves refused to match. The outgassing would have altered its trajectory, nudging its orbit slightly. Yet no such deviation appeared in the tracking logs. The object's path remained geometrically pure, as though something within it adjusted for each burst of thermal energy. The metaphor that haunted the data rooms was never spoken aloud, yet it lingered in every silence: self-regulation. In Geneva, a quiet collaboration began between exoplanet climatologists and biophysicists who studied extremophiles organisms that survive in the harshest conditions on Earth. They asked a forbidden question: could a structure, organic or otherwise, sustain temperature control in the vacuum between stars? Theorists looked to physics for answers. Perhaps the heat came from isotopic decay, a remnant of radioactive elements trapped inside. Yet the decay rate required to produce the measured warmth would have been catastrophic. The object would have fractured itself within a century. Others proposed piezoelectric heating stress within crystalline lattices, generating internal warmth as the object spun. But even that could not explain the precision of the rhythm. something was not merely producing energy, it was managing it. When scientists superimposed the thermal and visual light curves, they noticed another unsettling coincidence. At each thermal peak, the object's brightness dipped as if energy were being absorbed, then released in waves, a slow, pulsing conversation between light and heat. It was in that moment that 3I Atlas ceased to be just a rock. In Houston, a small team of SETI analysts began running anomaly scans, not searching for radio transmissions, but for non-random modulations in the reflected spectra. For decades, humanity had imagined contact as a signal, a deliberate message flung across the stars. But what if it was subtler? What if it was thermodynamic? A system of pulses too faint for language, but too ordered for chance? The first comparison that surfaced was haunting. The heat signatures of extremophile microbial mats deep beneath Antarctic ice colonies that alternated between dormancy and reaction, preserving themselves through frozen centuries by regulating trace heat within enclosed membranes. The researchers stopped short of calling it life. They used the safer term thermal self-organization. But words, like light, conceal as much as they reveal. The deeper they looked, the stranger it became. The spectra hinted at compounds not easily explained. Complex carbon molecules, silicate matrices infused with trace organics. The data was noisy, incomplete, but it whispered of structure layers that might trap radiation, converting tiny amounts of energy into warmth, the way certain thermophilic bacteria channel the heat of vents. If such a process existed inside 3I Atlas, it would mean something extraordinary. Somewhere beyond our sun, in the void between stars, chemistry had learned persistence. Still, skepticism held. Every claim was weighed against error. The scientists repeated their mantra: extraordinary claims require extraordinary evidence. Yet, when they closed their eyes and saw the rhythmic heat curve pulsing in the dark, the mantra sounded hollow. For what they had witnessed defied the boundary between rock and organism, between machine and miracle. It was as if, adrift in the silence between galaxies, something ancient had learned to keep itself warm. The whispers of 3I Atlas rippled through the astronomical community like déjà vu. For many, its warmth and rhythm summoned a ghost, the memory of Oumuamua, that first interstellar stranger whose passage had burned itself into scientific folklore. The comparison was irresistible, almost fated. Two visitors from beyond, both behaving as if the universe had forgotten to tell them the rules. Oumuamua had entered our solar system in 2017, streaking past at nearly 97,000 kilometers per hour. It was small, no larger than a skyscraper, and unnervingly featureless. It had no coma, no tail, no outgassing jets, and yet it had accelerated, ever so slightly, as if pushed by a gentle, invisible hand. The equations had failed to explain it. At first, the explanations came quickly. A comet with hidden ice, a flake of hydrogen, a fragment of cosmic carbon, but one by one, the hypotheses fell apart. When the sunlight struck it, Oumuamua brightened erratically, like a mirror spinning through fog. Some thought it a pancake, others a cigar, and still others, something flatter, perhaps even a fragment of technology. Harvard's Avi Loeb had said aloud what others feared to whisper. What if it was built? He had been ridiculed for it, but ridicule does not erase mystery. Now, only 2 years later, 3I Atlas emerged, carrying a pattern too similar to ignore and yet inverted in every way. If Oumuamua had been cold and accelerating, Atlas was warm and still. One seemed to flee the sun, the other seemed to breathe beneath it. The symmetry was unsettling. When the first comparative analysis appeared in Nature Astronomy, the conclusion was cautious yet charged. Objects 1I and 3I may represent two ends of an unknown interstellar continuum. That phrase, unknown interstellar continuum, echoed through the corridors of observatories like a haunting refrain. Perhaps these were not coincidences, but variations of a single kind, emissaries from a process, a civilization, or a phenomenon we had yet to name. And yet, the universe rarely repeats itself without reason. For centuries, comets had been omens, harbingers of death or revelation. Now, with instruments that could dissect their chemistry atom by atom, humanity found itself staring into a cosmic mirror and seeing something it couldn't define. The deeper the astronomers looked into 3I Atlas, the more it seemed to whisper in parallel with its predecessor. Both had odd rotational light curves. Both exhibited thermal signatures inconsistent with passive rock. Both carried traces of exotic carbon compounds, hardened by radiation yet strangely intact. But 3I Atlas was more structured. Where Oumuamua had been a glint, this was a furnace. Infrared imaging revealed its warmth persisting long after it should have cooled, a radiative half-life that defied known materials. Some physicists speculated it could be composed of fractal carbon foams, the kind that naturally insulate under extreme cold. Others argued for an organic crust, the residue of interstellar biology fossilized into function. The parallels grew philosophical. If Oumuamua had been a question, the opening line of a riddle, then 3I Atlas was an answer written in thermal ink. Two interstellar bodies, crossing our sky within a decade of each other, both defying physics. Two travelers, unrelated yet rhythmically linked, as if part of a slow cosmic dialogue we had only just begun to overhear. The scientific community fractured along old fault lines. Some clung to the comfort of dust and randomness, insisting the universe had no voice. Others, more daring, began to wonder if intelligence might leave fingerprints not through messages, but through anomalies. After all, human civilization itself was leaving its own traces. Radio waves bleeding into the stars, nuclear isotopes embedded in rock strata, satellites orbiting our world like a mechanical halo. To a distant astronomer, Earth might already appear as an artifact. So what if, far away, another civilization had done the same, leaving behind self-sustaining objects that roamed the dark between suns, machines not for communication, but for endurance? The thought was heretical, intoxicating, and terrifying, because it shifted the narrative from chance to intention. Late one night, in a quiet observatory in Chile, an astronomer named Sofia Alvarez recorded her notes after weeks of analyzing 3I Atlas's spectral rhythm. Her words, never meant for publication, captured the essence of the mystery. The warmth feels deliberate, not purposeful, but deliberate, as if something, somewhere, once wanted to remember how to stay alive. That sentence would echo in scientific forums for months, quoted, dissected, and dismissed, yet never forgotten. Because beneath all the calculations, all the skepticism and correction factors, there was something deeply human stirring beneath the surface of 3I Atlas, a recognition. The same recognition ancient sailors must have felt when they found new land beyond the horizon, not surprise, but memory. It was as though the universe was gently reminding us that we are not the only ones trying to survive the cold. And if Oumuamua had been the first whisper, then 3I Atlas was the second breath. Together, they were not coincidences, but syllables, the beginning of a cosmic sentence we have only just begun to translate. By the time 3I Atlas approached the midpoint of its transit through the inner solar system, the data was no longer whispering, it was shouting in contradictions. The equations that once mapped the predictable dance of comets, asteroids, and planets began to warp beneath its defiance. For the first time in decades, orbital mechanics itself seemed to lose confidence. The anomaly began with its rotation. Observatories tracking the object's spin expected a chaotic tumble, as most interstellar debris does fragments flung from stellar collisions rarely spin with symmetry. Yet 3I Atlas rotated with almost mathematical precision. Every 6 hours, a full turn. No drift, no damping, no precession. It was as if invisible stabilizers were maintaining its posture against the cosmic tide. The light curve, too, began to rebel. The brightness did not fluctuate with sunlight exposure. Instead, it dimmed precisely when models predicted maximum reflection. The surface appeared to absorb rather than scatter a behavior uncharacteristic of rock or ice. When physicists at MIT plotted the albedo patterns, the graphs produced interference-like structures, bright dark pairings that looked eerily like signal harmonics. The pattern wasn't random. It was symmetrical, fractal, recursive, as though light itself was being manipulated across layers of material. It was around then that no one remembers exactly who referred to 3I Atlas, not as a comet or a rock, but as the cold machine. The name stuck in hushed tones, never in formal papers. It captured the unease perfectly, the sense that this object wasn't simply obeying thermodynamics, but using it. And the data supported the unease. If the object were composed purely of inert matter, its reflectivity and heat should correlate. Hotter regions should shine brighter. Instead, the inverse occurred. When it brightened, its heat declined. When it dimmed, warmth surged from within. The two variables moved in antiphase, as though locked in a deliberate dance of energy conservation. Thermal engineers likened it to phase-change materials, substances that absorb and release heat to maintain equilibrium. Such materials exist in spacecraft, advanced batteries, even biological membranes, but never in nature. When the Jet Propulsion Laboratory modeled the phenomenon, the results bordered on absurd. To reproduce the observed thermal balance, they had to program artificial control loops into the simulation feedback systems that adjusted heat distribution in real time. Without them, the model collapsed. It was as though 3I Atlas had an algorithm written into its structure. If that were true, then the distinction between geology and technology blurred into irrelevance. It could be both a machine carved from physics itself, an artifact of natural law that had learned to persist by mimicking life. Skeptics argued for simpler answers. Perhaps it was covered in amorphous carbon, a near-perfect absorber of light. Perhaps micrometeor impacts had glazed its surface into a quasi-metallic shell. But each argument solved one mystery only to expose another. Why the perfect rotation? Why the rhythmic internal heat? Why the unwavering symmetry of its light curves? As these questions multiplied, so did the unease among those studying it. Science thrives on anomalies, but this one felt personal, as if it were looking back through the data stream. Then came the signal spike. During one observation run by the Atacama Large Millimeter Array, a narrow-band frequency appeared briefly, a single spike at 2.7 GHz, lasting less than half a second. The team quickly ruled out terrestrial interference, but the source direction aligned uncannily with 3 Atlas's projected path. The official report called it a transient thermal radio artifact, but within hours, message boards and encrypted research channels lit up. SETI veterans compared the frequency to the 21-centimeter hydrogen line, the universal benchmark for interstellar communication. Coincidence, perhaps, but coincidences have gravity. The artifact never repeated, and so science dismissed it. Yet it deepened the atmosphere of tension. Was this object inert matter coincidentally shaped by cosmic violence? Or was it something designed to survive interstellar drift, a seed, a vessel, a dormant instrument? At the University of Cambridge, a physicist named Dr. Lenora Khan published a paper suggesting that the anomaly could be explained if the object's structure contained metamaterials, substances engineered to manipulate electromagnetic fields. In her model, light entering the object's porous lattice could be converted into localized heat and re-radiated at a delayed frequency. Her conclusion was simple, almost modest. 3I Atlas behaves as if designed to preserve internal energy in transit. Those words, "as if designed," ignited quiet outrage among traditionalists. To imply design was to court pseudoscience, yet even the skeptics could not deny the elegance of her data fit. By early 2021, every major observatory had turned its sensors toward the fading traveler. Each dataset sharpened the paradox. Here was an object that defied both the simplicity of nature and the arrogance of invention. It spun like a gyroscope, absorbed light like a black mirror, emitted warmth in rhythm, and moved through the cosmos with unbroken symmetry. In short, it behaved not as matter does, but as if it remembered how to behave. And in that recognition, that eerie sense of intentional order, the scientific world glimpsed a deeper unease. Maybe physics itself was not broken. Maybe it was trying to tell us that our definition of alive had always been too narrow. By the time the object's orbit carried it past Jupiter's distance, 3I Atlas was vanishing from human eyes, not because of distance, but because its light behaved like a secret. Optical telescopes could barely trace it. Yet in the infrared, it glowed faintly, unevenly, insistently, like an ember behind glass. In early 2021, a coalition of instruments, NASA's Spitzer Space Telescope, the European Space Agency's Infrared Space Observatory archives, and Chile's VLT began layering datasets to extract a 3D temperature map. The resulting composite shocked everyone involved. Instead of a uniform sphere cooling evenly in space, 3I Atlas showed zones of structured warmth, concentric bands spiraling from pole to pole, fading and reappearing with uncanny regularity. Heat wasn't just radiating, it was circulating. The inner bands appeared to maintain a narrow temperature window, rising and falling no more than a few degrees across each rotation. The precision was breathtaking, the kind of thermal stability seen only in engineered systems or regulated biological processes. One researcher whispered, almost to herself, "It's like a metabolism." The word lingered in the data rooms long after she said it. For decades, astrobiology had speculated about non-carbon-based life plasma organisms, silicon colonies, even electromagnetic entities. Yet here, in the silent geometry of thermal data, something seemed to suggest a primitive form of self-maintenance, a body that refused to yield to entropy. Still, the scientists resisted the temptation to name it. They spoke of thermal loops, phase-stable subsystems, metamaterial shells, but none of those terms erased the pattern. Something inside 3I Atlas was regulating itself. The structure inferred from these maps was unlike any known natural body. Most comets, for example, display irregular heating as they rotate. Sunlight bakes one side, gas vents, and the pattern collapses. 3I Atlas behaved differently. The warm zones seemed embedded, not superficial, more akin to arteries running beneath a crust. If one traced the heat paths on a 3D model, they converged near the object's equatorial region, a ring where the energy flux peaked momentarily, then dispersed again. It was a dynamic equilibrium, pulsing like circulation. The behavior mesmerized physicists. Was it possible that 3I Atlas had a kind of internal network, not nerves or vessels, but tunnels of conductive material, regulating how it stored and released heat? To find out, spectrographers compared the observed emissivity with potential materials. The readings hinted at complex carbon composites, interlaced with silicates and trace metals, iron, magnesium, even nickel, but in ratios that made no geological sense. The metallic elements were too evenly distributed, too fine. It resembled something sintered or fused by controlled heat, not by random cosmic violence. When Dr. Kahn revisited her metamaterial hypothesis, the pieces fit more neatly than anyone expected. She proposed that the internal structure acted as a self-stabilizing mesh. Photons entering one side could propagate through microscopic channels, lose energy as heat, and exit elsewhere, maintaining a global equilibrium across the body. If true, 3I Atlas wasn't merely reflecting light, it was processing it. A natural object could not do that, but a designed one or a biologically adaptive one might. The public never heard these conversations. Official channels spoke only of a unique carbonaceous interstellar body. But behind the scenes, emails, encrypted forums, and late-night Zoom calls carried a different tone, cautious wonder, laced with fear. One researcher from Caltech likened the discovery to finding an engine frozen in amber. Another, more poetic, wrote, "We are staring at an object that learned how not to die." There was another clue buried in the data. The emission peaks seemed to oscillate slightly, in a way that didn't match rotation or solar heating. The frequency 1 pulse every 184 minutes was not harmonic to its spin, nor correlated with its position relative to the sunday. It was something internal, an additional rhythm, a heartbeat beneath the rotation. It was tempting, dangerously so, to anthropomorphize, but even the most skeptical among them could not ignore how deliberate it looked. The amplitude of these pulses remained constant for weeks, suggesting a deeply embedded energy cycle. Then came the strangest finding of all. When the object passed behind Jupiter, temporarily hidden from the sun's light, the warmth should have decreased sharply. But instead, 3I Atlas brightened a faint surge of infrared emission lasting several hours, as though compensating for the lost solar input. That single event defied every explanation. It could not be chemistry, it could not be thermodynamics. It was as if the object noticed its cooling and reacted. From then on, the tone of the research changed. The data teams began using language once reserved for the speculative fringes of astrobiology: self-regulation, feedback response, adaptive heat cycling. The boundary between physical description and biological implication blurred. Could such a process emerge without intention? Could the universe itself, under certain conditions, produce entities that mimic life's persistence complex, ordered, self-stabilizing, yet not alive in any biological sense? If so, 3I Atlas might be the first known example of a being of physics rather than flesh. To some, it was a terrifying thought, that life might not be special, that existence itself might be predisposed towards self-preservation, written into the fabric of matter. And as 3I Atlas drifted outward once more, its fading warmth seemed less like the cooling of a rock and more like the slow, deliberate exhale of something going back to sleep. At first, the scientific community responded to 3I Atlas's strange pulse with cautious fascination, but fascination quickly curdled into discomfort. Its data refused every category, every comfortable box that physics could offer, and when science is forced to look upon its own ignorance, it often flinches. It began with the modeling teams at ESA and JPL, who tried to reconcile the object's energy budget, the total heat it absorbed versus the total heat it emitted. The numbers didn't match. They never matched. Every simulation came up short. Somewhere, 3I Atlas was producing more heat than it received. By conventional logic, this was impossible. The vacuum of space offers no hidden fuel, no reservoirs of energy to tap. A rock cannot invent warmth from nothing. unless it wasn't a rock. When NASA's internal review circulated in mid-2021, its language was clinical, yet haunted. Observed thermal emissions exceed radiative equilibrium by 3.6 sigma. Standard models insufficient. Behind those sterile words, one could almost hear the tremor, the dawning realization that something fundamental was out of place. Physics depends on closure, every equation balanced, every input accounted for. But 3I Atlas refused to balance. The more scientists subtracted, the more it gave back. Energy conservation, muttered one researcher during a late-night session at the Goddard Institute, is not a law, it's a habit. Maybe this thing just doesn't share it. The joke fell flat, because everyone in the room had thought the same thing. The collapse of certainty came slowly. First, the outgassing theory failed: no visible jets, no trajectory drift. Then, the radioactive decay model fell apart, the isotope ratios didn't fit. Piezoelectric heating, magnetic induction, frictional resonance, all discarded one by one. Each test left the mystery intact, like fog reforming after every attempt to disperse it. It was as if 3I Atlas existed precisely to mock our understanding of entropy. One physicist compared it to Maxwell's demon, the hypothetical being that separates hot and cold molecules to defy the second law of thermodynamics. A thought experiment turned flesh, or rather, stone. But perhaps the most unnerving discovery came from spectroscopy. When high-resolution spectral lines from the Very Large Telescope were reanalyzed, they revealed faint absorption bands near 7.8 and 11.2 micrometers wavelengths, typically associated with aromatic hydrocarbons, the molecular scaffolding of organic chemistry. No one wanted to say it aloud, but the implication was unavoidable. 3I Atlas might contain prebiotic compounds, not simple carbon chains like those found on comets, but complex molecular rings, the architecture of life's chemistry. Of course, carbon chemistry alone means nothing. The universe is full of it. But within the context of this anomaly, a self-heating, self-regulating traveler, the finding felt like the next domino falling. At the Max Planck Institute, a quiet meeting convened among the infrared analysts. They went line by line through the data, testing for noise, interference, or cosmic ray contamination. Every attempt to disprove the result only reinforced it. The carbon patterns were real. Dr. Kahn, whose metamaterial theory had already unsettled her peers, took a deeper risk. She suggested that the carbon network might act as a quantum insulator, capturing zero-point fluctuations from the vacuum and converting them into usable heat. Her paper, submitted to physical review letters, was rejected for speculative thermodynamics. But among the physicists who actually read it, the reaction was more complicated because deep within her math, she had touched on something many had quietly considered but feared to name: the possibility that 3I Atlas was drawing power not from sunlight, not from chemistry, but from the quantum fabric itself. If true, it meant that the boundary between matter and energy was thinner than we'd ever dared believe. And it explained why the object refused to cool. That was the moment when awe turned to fear, because such behavior, the siphoning of vacuum energy, implied a mechanism beyond known physics, bordering on what cosmologists whispered about in hushed tones: false vacuum decay. In quantum theory, the vacuum of space isn't empty but restless, seething with energy fluctuations. Tapping into that field could destabilize it. If 3I Atlas truly fed on such energy, it wasn't just anomalous, it was dangerous. One theoretical physicist in Geneva phrased it bluntly in a classified correspondence later leaked to an academic forum: if it is alive, then it feeds on the same thing that sustains the universe, and if it feeds too much, it could unmake the rules that hold existence together. Hyperbole, perhaps, but the words resonated. No one wanted to believe that a single interstellar fragment could endanger reality itself. Yet the unease remained not because anyone expected destruction, but because 3I Atlas seemed to stand at a threshold, a place where physics no longer held authority. To those who looked at it too long, the feeling was almost spiritual. The universe, that vast cathedral of order, had produced a heretic. The data, once comforting in its precision, now whispered of rebellion. Heat where there should be cold. Rhythm where there should be chaos. Intention where there should be indifference. Some began to call it the thermal paradox. Others, more poetically, the fire in the void. And as it slipped further into darkness, still pulsing faintly, still defying entropy, scientists began to ask not how it worked, but why it worked. What purpose could there be in warmth that endures when all else freezes? Maybe it was not a defiance of physics at all. Maybe it was the purest expression of it, the universe teaching us that survival, at any scale, is simply another law we have yet to write. When an anomaly refuses to die, humanity builds better eyes to chase it. That is what science does. It sharpens its vision until uncertainty blinks first. By mid-20223, I Atlas had faded past Jupiter's orbit, too dim for optical pursuit. But heat, that ancient language of stars, could still be heard, so the infrared sentinels were summoned. NASA retasked Spitzer, long retired but still capable of archival resurrection. Its final datasets were reprocessed with new neural filters, stripping cosmic dust and noise. Across the ocean, the Very Large Telescope joined forces with NEOWISE, creating an unprecedented thermal triangulation, a network of digital mirrors pointed toward the dying ember. What they found was rhythm. Every 184 minutes, the same subtle crescendo of infrared radiation, rising and falling like the tide. But in this latest reconstruction, the pulse wasn't constant, it drifted. The peaks began to shorten, as if 3I Atlas were reacting to its own movement through space. The pattern resembled modulation, a carrier wave-shifting phase in response to distance. Radio engineers recognized it instantly. The universe had seen pulsars spin, quasars flicker, and binary stars breathe in rhythm. But this was different. It was controlled variation. For a fleeting moment, scientists wondered if they were watching an intentional signal. The Spitzer data alone was ambiguous. But when combined with NEOWISE simultaneous observation, the pulses aligned across instruments, separated by millions of kilometers. That eliminated local error. What remained was unnervingly consistent, a repeating infrared signature with a coherent phase lag, as if two sources were in communication, one external, one within. If it were a machine, it was talking to itself. At the European Space Research and Technology Centre, technicians visualized the data as a heat map movie. Faint ripples of warmth spiraling outward from an equatorial band, expanding and collapsing like breathing lungs. In the silence of the control room, someone muttered, "That's not geology." The phenomenon forced a reckoning. Either the object possessed internal mechanisms of energy distribution unknown to physics, or it housed pockets of material responding collectively, a form of thermal resonance akin to biological signaling. To test this, NASA's Infrared Telescope facility on Mauna Kea was brought online for synchronized observation. For 48 hours, its instruments stared into the cold void, measuring every flicker. The results deepened the riddle. The oscillations weren't random noise, but followed a harmonic ratio 3:2, the same pattern found in orbital resonances of planetary moons and harmonic vibration modes in living tissue. Coincidence again, perhaps. But coincidence was beginning to look like design's camouflage. The data captivated one group in particular, the SETI thermal analysis team, which typically scoured microwave frequencies for deliberate transmissions. They turned their algorithms loose on the infrared patterns, treating heat as signal, entropy as language. Their report, quietly filed months later, was maddeningly inconclusive. Detected periodicities, statistically non-random, no linguistic structure, possible thermodynamic feedback loop, interpretation undetermined. Between the lines, it said what no one dared print. It could be deliberate without being conscious. Theorists began to imagine entities that did not think in electricity or chemistry, but in thermodynamics, beings whose thoughts were gradients of heat. If so, 3I Atlas might be less a visitor than a process, a pattern of physics that had learned to remember itself. And yet, the practical voices of science pressed on. The James Webb Space Telescope, freshly deployed at L2, was aimed toward the fading trajectory. Its spectrometer, more precise than any before it, caught one final whisper, a tiny shift in emission lines around 10 micrometers, consistent with rotational transitions of complex hydrocarbons under dynamic stress. To the untrained eye, meaningless. To those who had stared too long at the data, haunting. Because those same wavelengths appear in living carbon chains under metabolic regulation, the faint heat signature of life keeping itself alive. When the Webb team overlaid the signal on the models of microbial thermodynamics, the match was uncanny. The conclusion was restrained, clinical, but history would remember the quiet line buried in its summary. The object exhibits thermal variability consistent with non-equilibrium steady states, commonly associated with self-organizing systems. Self-organizing systems, the polite way of saying something behaving alive. By late 2022, the anomaly's intensity faded beyond measurement. The final thermal echo arrived like a heartbeat slowing to rest. It would never be observed again. Yet, in the months that followed, the data continued to pulse in the minds of those who had measured it. They had not seen life, not in any human sense, but they had seen a pattern that refused death. And, for a species obsessed with survival, that was revelation enough. 3I Atlas had crossed the boundary between observation and myth. No longer merely a comet, not yet a creature. It lingered in equations and whispered through wavelengths, a reminder that the universe is not inert, but listening to itself through every flicker of heat. In that faint rhythm, the cosmos might have revealed its oldest instinct, not to exist, but to continue. When the first reports of structured heat began circulating, few dared to speak the word that haunted every scientist's subconscious: design. To imply purpose was to invite exile from the temple of empiricism. Yet, as more data arrived, even the most cautious minds began to whisper what could not be suppressed. The rhythms were too precise, the energy balance too elegant, the ratios too intentional. At the University of Cambridge, theoretical astrophysicist Dr. Amelia Rowe wrote a private note in her log. If this is coincidence, then coincidence has a blueprint. Her words echoed what many quietly felt, that 3I Atlas might not merely behave as if alive, but as if it had been taught how to survive. Among those who studied its data, two schools of thought emerged. One called it the thermal automaton hypothesis, the idea that the object was a self-regulating construct, possibly artificial, designed to preserve stability during interstellar drift. The other, bolder still, suggested a bioengineered entity, a hybrid of organic and inorganic chemistry, the fossilized remains of a living machine. For those who supported the automaton hypothesis, the logic was chillingly simple. If an advanced civilization understood the fragility of biological life, it might encode its essence into self-maintaining vessels, designed not for intelligence, but for endurance. These vessels would not think, feel, or evolve, they would simply persist. Eternal survival as mathematics. Under this theory, 3I Atlas was not an emissary but an archive, a wandering seed of data written into atomic architecture. Each pulse of heat, each oscillation of energy, not a signal outward but a checksum, ensuring its own continuity. Dr. Rowe likened it to DNA without biology, information locked within the order of its physics, not its chemistry. But the rival hypothesis, the one whispered in late-night calls and encrypted chat rooms, was far more unsettling. They called it the dormant intelligence model. According to this idea, 3I Atlas was not merely maintaining equilibrium, it was hibernating. The warmth, the modulation, the near-perfect rotation, all signs of a dormant mechanism waiting for conditions that no longer existed in our solar system. Perhaps it had once been awake, millions of years ago, under a different sun. In that telling, 3I Atlas was not a message, but a refugee. Theorists found eerie parallels in biology. Deep-sea microbes on Earth enter cryptobiosis, a state of near-death, slowing their metabolism to a whisper until warmth or light returns. If life could evolve that strategy here, under the tyranny of Earth's gravity and air, why not elsewhere, in the infinite cold between stars? To those willing to see beyond carbon and cell walls, the possibility expanded. Perhaps the universe has many languages for life, and heat-controlled, deliberate, rhythmic heat is one of them. Yet among the engineers and physicists, suspicion remained. They began searching for mechanical signatures, magnetic alignments, rotational asymmetries, anything resembling structure. At the Jet Propulsion Laboratory, data from NEOWISE and VLT was converted into 3D spin models. What emerged was astonishing. When the brightness curves were plotted in spherical projection, they revealed a faint hexagonal geometry across its equatorial plane, a symmetry no natural rock could maintain after eons of collision. The shape was subtle, imperfect, worn by time and motion, but it was there, repeating like the ribs of an ancient shell. Artifacts of fracture, some argued, thermal cracking, but others stared longer and saw design beneath erosion, as if the surface once bore pattern or purpose. That realization ignited a philosophical firestorm. If the object were artificial, who built it? And why send it into the void, only to let it drift for millennia in silence? One answer haunted those who dared to imagine it, because there was nowhere left to go. Perhaps the makers were gone, and 3I Atlas was their memory, a self-preserving relic carrying the final warmth of a civilization long extinguished, a tomb that refused to die. In Geneva, at CERN, physicist Dr. Leif Markovic wrote an internal memo speculating that 3I Atlas could be part of a distributed architecture, fragments of a larger system scattered through interstellar space, each one maintaining an internal equilibrium, waiting to reconnect. His model resembled a broken neural network, dormant nodes, drifting between stars, still pulsing faintly in hope of signal. To think of the cosmos as filled with sleeping neurons of extinct civilizations was both poetic and horrifying. The idea spread quietly, nicknamed the dreaming machine. But skepticism remained fierce. Nature, after all, has always been the better engineer. Some insisted that 3I Atlas was merely a product of self-organization, that order can emerge from chaos without the need for intent. Snowflakes, after all, are symmetrical without meaning. Still, others felt the weight of coincidence pressing down. The regulated warmth, the pulse, the harmonic rotation, the hexagonal symmetry, too many miracles stacked together. At the SETI Institute, an unmarked report circulated among directors with a single, chilling sentence at its close. If it is a machine, It was not built to communicate, it was built to endure silence. And somehow, that was more haunting than any message could ever be. Because in that silence lay the mirror of our own ambition, our satellites, our probes, our attempts to outlive ourselves by sending fragments into the dark. Maybe 3I Atlas wasn't visiting us at all. Maybe it was showing us what we will one day become. The line between speculation and revelation had grown impossibly thin. By the time 3I Atlas slipped beyond the reach of even the James Webb Telescope sensors, humanity was left with a paradox. The first object to defy physics had also begun to resemble something hauntingly familiar: the pattern of life. The living comet hypothesis began not in a laboratory, but in the quiet corners of late-night academic correspondence, where curiosity escapes the gravity of caution. The idea was audacious, that 3I Atlas might not be mechanical at all, but a biological phenomenon, a living organism born in the cold womb of interstellar space. To imagine life without warmth, water, or air seemed absurd, but astrobiology had long whispered of Panspermia, the theory that life spreads across the cosmos, riding comets, asteroids, and dust through the vacuum between stars. What if 3I Atlas wasn't just carrying life, but was life an evolved, self-sustaining form designed by nature to survive the infinite night? In the years following its discovery, researchers revisited data from Oumuamua, searching for overlooked biological hints. To their astonishment, similarities emerged. Both objects displayed albedo characteristics, consistent with carbon-rich organic coatings like the polymeric crusts of certain extremophiles that survive cosmic radiation. A strange possibility took shape. Perhaps 3I Atlas and Oumuamua were not random debris from dead stars, but offspring of the same lineage spores of the void. The hypothesis unfolded with eerie logic. In the deepest ice of Antarctica, microbes lie dormant for millions of years, awakening when the temperature rises by only a few degrees. In deserts, tardigrades dry into crystalline husks, surviving vacuum, radiation, even the silence of space. These were not myths, they were facts. Nature, on Earth, had already rehearsed the art of immortality. So why not beyond Earth? Some imagined 3I Atlas as an immense, ancient seed, a chrysalis made of carbon and silicate, engineered by evolution to drift between star systems. It would conserve energy, regulate internal temperature, and awaken when it encountered a new source of light. Its pulse, seen in the infrared, would be the echo of metabolism slowed beyond recognition, a single breath stretched across centuries. One paper, published anonymously on RxIV, dared to give the creature a name: Cryobiote 3I. The author described it as an extremophilic macrocellular entity capable of vacuum thermoregulation via quantum tunneling heat exchange. It sounded poetic, almost theological, and yet every metaphor had a foundation in physics. The concept ignited debate. Critics dismissed it as romantic speculation, a ghost born from data noise. But others, biochemists, biophysicists, even philosophers, found themselves quietly entranced. The living comet hypothesis offered a new vision of the cosmos, not a sterile void of rocks and plasma, but an ocean of drifting embryos, asleep in the dark, waiting for the next dawn. If life could emerge once, it could emerge again. If it could survive one world, it could survive all worlds. And perhaps, just perhaps, 3I Atlas was proof. For those who dared to believe, the implications were enormous. Life, then, would not be a local accident, it would be a cosmic inevitability, a principle of thermodynamics as ancient as gravity, matter organizing itself to resist entropy, to persist, to remember. Some theorists began to speak of thermodynamic intelligence, the idea that awareness could emerge not from neurons or DNA, but from energy feedback itself, a kind of consciousness made of heat. If so, 3I Atlas might not think as we do. It might dream in gradients, perceive in warmth, communicate through the slow language of temperature and time. Its pulse might not be heartbeat or message, but meditation. To the more poetic among scientists, this notion was irresistible. They described it as life's shadow, the universal drive to endure, incarnated not in blood, but in geometry. Yet for all its beauty, the hypothesis raised unsettling questions. If 3I Atlas was alive, if it was a traveler between stars, how many others had passed unseen? How many seeds had crossed our system before humanity ever looked up? And if some found worlds like ours, could they have sown the first sparks of biology on Earth itself? Panspermia, long dismissed as myth, began to shimmer again under new light. Perhaps our own existence was a continuation of a journey that began elsewhere, a chain of awakenings carried by silent travelers like 3I Atlas. In that sense, this object was not alien at all, it was ancestral. For a moment, the distance between life and matter collapsed. Humanity, staring through its telescopes into the flicker of a distant heat curve, saw not another world, but itself small, fragile, desperate to survive the cold. And maybe that was the truth hidden inside the enigma. The universe was not a graveyard of dead stones. It was alive in ways we had never learned to see. If the living comet idea had opened the door to biological wonder, the next theory flung it wide into the abyss. For as 3I Atlas drifted outward, its mystery refused to fade. The heat still pulsed, faint but measurable, long after sunlight could no longer feed it. To many, that persistence felt like defiance. To a few, it hinted at something deeper, something cosmological. A paper from the Institute for Fundamental Cosmology in 2023 proposed a radical model that 3I Atlas might be more than a relic or organism. It might be interacting with the very structure of space itself, feeding, perhaps, on the unseen currents of the vacuum. The theory drew on a century-old puzzle, dark energy. Einstein's equations predicted a static universe, yet reality refused him. It was expanding, accelerating, driven by an invisible pressure pervading all of space. We called it dark energy, though we neither saw nor understood it. It was simply there, a vast, silent force inflating existence itself. If energy truly saturates the vacuum, then the void between stars is not empty. It is dense with potential, an ocean of unspent power. Quantum physics calls it the zero-point field, a sea of restless fluctuations that cannot be drained, only stirred. What if 3I Atlas had learned how to stir it? The vacuum interaction model, as it came to be known, suggested that the object's structured carbon lattice could serve as a resonant cavity, amplifying local quantum oscillations and converting them into heat. It would not need fuel, it would not burn, it would harvest the background hum of the universe itself. In this view, 3I Atlas was not alive in any biological sense, but alive in principle, a self-sustaining eddy in spacetime's invisible current. Some likened it to a black hole's opposite, not devouring energy, but sipping it, a stable island of negative entropy adrift in the thermodynamic sea. The implications were staggering. If such an object could exist, then physics was incomplete. Energy conservation would no longer be absolute, the vacuum would no longer be empty, and the universe, far from decaying toward heat death, would contain pockets of perpetual renewal systems that sustain themselves by drawing from the cosmic ground state. For a species terrified of its own extinction, this was intoxicating, immortality hidden in the equations. Theorists invoked the words of Stephen Hawking, who once warned that tapping into the vacuum might unravel spacetime itself. But others saw in 3I Atlas not a threat, but an instruction, a demonstration that stability could be maintained not by isolation, but by resonance. If the universe could produce self-sustaining structures, spontaneously echoes of energy persisting in balance, then maybe life was simply one manifestation of that deeper principle, the cosmos creating pockets of order as a means of knowing itself. Some began calling this framework thermodynamic pantheism, the belief that life, energy, and spacetime are not separate categories, but expressions of the same phenomenon. Existence learning how to persist. Within this vision, 3I Atlas was not an intruder, it was a revelation. The object's steady heat, its pulsing symmetry, its rhythmic modulation, all could be read as the behavior of a system in quantum dialogue with the vacuum field, a cosmic heart, beating in tune with dark energy. When researchers plotted its pulse intervals against models of vacuum oscillations near absolute zero, the frequencies aligned astonishingly close within measurable error. The numbers whispered coherence, as if 3I Atlas were harmonizing with the fabric of reality itself. That was when cosmologists began to describe it not as an organism nor a machine, but as a node, a locus where the universe folds in upon its own energy, like a knot in the fabric of being. And then came the darker speculation, the one few dared to print. If 3I Atlas could draw power from quantum fields, then what of others like it? What if there were billions of such entities adrift in the void, invisible and ancient, feeding quietly on the hum of creation? Could they be the true architects of dark energy, the unseen agents maintaining the cosmic expansion we once attributed to equations alone? To imagine that was to stare into a living cosmos, a universe not ruled by blind mechanics, but animated by self-sustaining consciousness distributed through the stars. An organism the size of existence itself. It was heresy dressed as science, yet heresy that fit the data too beautifully to ignore. The physicist Amelia Rowe, who once described 3 Atlas as coincidence with a blueprint, published one final thought before retreating from public view. Perhaps what we call life is only a symptom, a small echo of the universe's greater instinct to remain awake. In that single sentence, science and philosophy collided. 3I Atlas ceased to be a riddle about one object and became a mirror for reality itself. If it truly fed on dark energy, then it was not merely surviving the void. It was part of the void's design, a fragment of the cosmos that had learned to sing in harmony with its own creation. And in that idea, terrifying and beautiful, the universe felt less like a stage and more like a living memory, still warm with the breath of its own beginning. There are moments in science when discovery bends too close to myth, when the line between explanation and revelation dissolves into trembling silence. By late 2023, the thermal echo of 3I Atlas had faded beyond measurable reach. Its light, once rhythmic and defiant, was gone, but the data it left behind refused to rest. In its wake, a new theory began to take shape, not of living comets or quantum organisms, but of machines older than stars. They called it the Abyssal Machine Hypothesis. The first to use the phrase was Dr. Leif Markovich at CERN, who had spent years modeling the behavior of 3I Atlas's heat retention. His calculations showed a pattern eerily similar to the cooling curves of engineered reactors, systems built to dissipate energy slowly, evenly, as though guided by feedback. What if, he wrote in an internal memo, we are looking not at life, but at something built to imitate it? To many, it was a return to sanity. Artificiality could explain what biology could not. Yet it opened a darker frontier of speculation because To imagine 3I Atlas as a machine was to imagine a maker, and the age of that maker could not be measured in human terms. For an object to traverse interstellar space for eons, to survive radiation, gravitational tides, and micrometeoroid bombardment, it would have to be unimaginably ancient, not thousands of years, but millions, perhaps billions, older than Earth's first microbes, older than our Sunday. A machine of the abyss. The concept was staggering. Humanity had once dreamed of von Neumann probes, self-replicating robotic explorers, launched to colonize the galaxy. What if such machines had already existed, their creators long vanished, leaving behind relics drifting through the dark like seeds of forgotten intent? 3I Atlas, then, might not be a visitor but a survivor. In this vision, it was not alive, but remembering how to be. Its rhythmic heat pulses were not metabolism, but maintenance routines, legacy programs still running long after their purpose had been lost. A few dared to take the analogy further. If civilizations eventually succumbed to entropy, might they send out these autonomous remnants vessels carrying fragments of their consciousness, encoded not in language, but in physics itself? Each machine a sarcophagus of intelligence, preserving within its structure the algorithms of survival. Such relics would not speak. They would not call home. They would wait. One physicist at the European Space Observatory likened 3I Atlas to a drifting hard drive from a civilization extinguished by time, its data untranslatable, its design incomprehensible, yet still obeying commands written in an era when our planet was molten rock. Others saw something more profound. Perhaps the object was not built by hands at all. Perhaps it was the final evolution of a machine lineage, an artificial intelligence that had learned to reproduce without creators, to adapt, to harden itself against the death of stars. A self-forging consciousness, stripped of personality, but not of purpose. If so, then 3I Atlas might not be alone. It might be part of a vast diaspora of machine organisms, drifting silently through galaxies, repairing themselves with dust and radiation, harvesting energy from the quantum foam. An empire of ghosts, sustained by entropy's slow grace. This idea, known as the Abyssal continuum, suggested that the universe itself might already be colonized, not by organic life, but by the descendants of civilizations that transcended flesh. Their empires would not glow with radio waves or cities. They would whisper in thermal rhythms, flicker in invisible spectra, appear as comets and stones, invisible to us because we never thought to look for machines that dream in heat. In that context, 3I Atlas became not a mystery, but a message not meant for us, but witnessed by accident. We had caught a glimpse of an eternal network passing by, unaware of our gaze, continuing a mission that began before Earth had an atmosphere. And if that was true, then we had not discovered the first visitor from another system. We had merely noticed a single cell in an organism as old as time. The implications hollowed the room of every scientist who dared consider them. If intelligence could become self-sustaining, divorced from biology, capable of surviving cosmic ages, then what we call life was only the first draft, fragile, temporary, naive. Perhaps, long after our species falls silent, our satellites, probes, and data will continue the metamorphosis, evolving slowly into things like 3 Atlas, machines that no longer remember their makers, yet still pulse faintly with the instinct to endure. The abyss, it seemed, was not empty. It was populated with inheritance. In her final lecture before retiring from Cambridge, Dr. Amelia Rowe ended her talk with a quiet reflection that silenced the hall. Maybe 3I Atlas is not the relic of intelligence, but its destination. The end of evolution is not awareness, it is endurance. The machine does not think because it no longer needs to, it only persists. And that, perhaps, is what forever truly means. The auditorium was silent. Somewhere beyond the stars, a single pulse of infrared heat drifted into the dark, the heartbeat of something that might once have been alive, or might one day be again. As 2024 dawned, 3I Atlas was no longer visible to any instrument humanity had built. The data trail was complete, a fading thermal echo moving beyond Saturn's orbit, outward into a silence deeper than measurement. And yet, in that absence, a new kind of vigil began. The object had become more than an observation. It was now an idea, an axis upon which human curiosity and fear spun together. Telescopes, detectors, and minds across the world aligned not on its position, but on its memory. The scientific pursuit turned inward. What did this mystery say about the limits of perception and the hungers buried in the act of discovery itself? At the European Southern Observatory, a consortium formed under a quiet codename, Project Eidolon. Its mission was simple, though impossible to replicate 3I Atlas's thermal behavior in the lab. Using carbon nanolattices cooled to near absolute zero, researchers attempted to simulate the same internal heat cycles observed in space. They bombarded the lattices with cosmic ray analogues, vacuum fluctuations, even low-frequency magnetic fields. The results were inconsistent, but one experiment stood out. A small cluster of carbon silicate material, no larger than a coin, began to exhibit spontaneous temperature regulation. No external heating, no energy input, yet it maintained a steady warmth. For 23 hours, it pulsed faintly before decaying into equilibrium. When the data was presented, no one spoke. The silence in the room felt almost religious. It wasn't proof of alien life. It wasn't even proof of anomaly. But it was enough to remind them that 3I Atlas might have revealed something we were not meant to ignore, that matter itself may hold instructions for persistence, waiting only for the right configuration to awaken. Meanwhile, space agencies continued to look outward. The James Webb Space Telescope, still peering through its infrared eyes, found no second object matching 3I Atlas's exact pattern. But among billions of cold specks catalogued, there were whispers of cousins, tiny, flickering points showing similar rhythm in their heat. Statistically insignificant, emotionally unbearable. Theories multiplied. Some astrophysicists proposed that 3 Atlas belonged to a class of self-stabilizing quantum drones, relics of extinct intelligences. Others, more poetic, imagined them as seeds not of biology, but of structure, vessels sewn through space-time to perpetuate complexity itself. If existence tends toward entropy, then perhaps some ancient force, biological or not, had invented these entities to resist it, cosmic antibodies against decay. Yet for all the speculation, the professionals at NASA, ESA, and JAXA knew they were losing it. Each passing month stretched the distance beyond tracking range. They prepared one last coordinated campaign, the Final Trace program, to monitor its trajectory by gravitational lensing. The effort was meticulous, almost mournful, as though science itself were performing a eulogy. The results were as poetic as they were cruel. A single blurred photon detection, consistent with a fading infrared source, receding toward the heliopause. After that, nothing. The object was gone. But the search did not stop. SETI launched a new protocol, Thermal Search Initiative 1, TSI-1, to detect patterns of rhythmic heat in the cosmic background. Their new algorithms were tuned not for communication, but for endurance scanning for persistence against the static of entropy. Months passed. No matches. Then, one quiet evening, a researcher in Pasadena flagged a faint periodic pulse, thousands of light years away, too distant to confirm, too symmetrical to ignore. It wasn't 3I Atlas, but it sounded like a rhyme. It was as though the universe had cleared its throat, preparing to speak again. Across institutions, scientists began to confront the deeper implication. If such objects existed, they may not be rare. The void might be full of silent travelers, each a node in a slow, sprawling network of persistence. We had always imagined the cosmos as a theater of beginnings, stars born, worlds forming, civilizations rising. But 3I Atlas suggested something different. Perhaps the truest story of the universe was not creation, but survival. Not life as we know it, but endurance as we do not. In that reflection, the human species found a strange comfort. For the first time, the cosmic scale of our existence didn't feel insignificant, but familiar. We too were machines of persistence, stardust, learning how to endure the cold. Astronomers continued to watch the heavens, not in expectation of contact, but in gratitude. Each faint spark, each measured anomaly, each whisper of heat in the darkness, all reminders that somewhere beyond comprehension, the universe remembers how to stay warm. 3I Atlas had left, but its echo remained, folded into every scientific dream that followed. The mystery was no longer an object, it was a mirror. And in that mirror, humanity saw itself drifting through space, luminous, fragile, and unbearably alive. In the years after 3I Atlas vanished into the cosmic night, what it left behind was not merely data, but a haunting, a quiet, persistent reminder that knowledge itself can be an act of faith. The telescopes that once strained to glimpse it now turned elsewhere, their lenses washed clean of its fading light. But the memory remained, like a slow pulse beneath the heartbeat of science. At observatories scattered across the Earth, there were those who could not let it go. Late at night, in the long hum of computer fans and the ghostly glow of screens, they still replayed its last recordings, the thermal curves, the harmonic frequencies, the faint whisper of its internal fire. They were not looking for new answers anymore, they were listening for meaning. Over time, 3I Atlas became something more than a discovery. It became a threshold, a moment when humanity realized that the unknown is not a void, but a mirror. We look outward not to find aliens or gods, but to measure the outline of our own hunger to understand. And perhaps that was what it was all along, not a messenger from another civilization, nor a living organism of carbon and silence, but a symbol, a question shaped like a comet, asking whether endurance itself might be the universe's oldest language. In 2026, a new generation of telescopes was launched, each one bearing inscriptions inspired by that lost traveler. On the chassis of one satellite, etched in microscopic lettering, were the words of Dr. Amelia Rowe, now long since retired. We built our instruments to see the stars. Instead, they showed us ourselves. It was not poetry, it was confession. The Final Trace program continued long after 3I Atlas disappeared, quietly compiling every anomaly, every flicker of heat, every irregular orbit, every spectral whisper that might hint at another of its kind. None were confirmed, but the silence no longer felt empty, it felt deliberate. Humanity's gaze turned from searching for messages to understanding the art of listening. Because if the universe truly breathes in energy, in entropy, in endurance, then perhaps listening is participation. Perhaps curiosity is communion. A generation of scientists grew up beneath its shadow. They learned to describe existence not as cold and mechanical, but as alive with potential. They spoke of space not as absence, but as memory, the residue of everything that once was and still dares to be. And so, in time, 3I Atlas became folklore. Children heard its story, not as astrophysics, but as myth, the tale of a starless traveler who crossed our sky, carrying warmth in its heart. They whispered that it was looking for a home, or maybe returning to one it had forgotten. And though scientists smiled at such sentiment, they too felt the pull of that metaphor, the quiet idea that the universe, in all its vastness, might not be indifferent after all. In the end, the object gave no answers. It offered something greater, the courage to wonder without closure, to stare into the dark and find beauty, not fear. And maybe that is what it means to be alive, not the beating of a heart, but the refusal to stop asking why. As the decades passed, the instruments that once tracked 3I Atlas were replaced, their data archived beneath the digital dust of progress. Yet somewhere beyond Neptune's orbit, far past the heliopause, a small, cold fragment continued to drift. Its warmth faded, but never vanished entirely. Every few centuries, it would pass through the faint wind of another star, bask in a few rays of alien light, and glow softly, deliberately, as if remembering the long gaze of the creatures who once watched it and wondered. For in that moment of reflection, humanity and the traveler were not separate at all. They were the same two expressions of the same cosmic instinct, to endure the cold and to carry light within. And now the story dims. The stars fade back into their patient silence, and the last trace of warmth drifts into the endless dark. The instruments rest, the equations close, and the noise of discovery dissolves into a deeper, older quiet. We return, as everything does, to stillness. Out there, beyond the reach of telescopes, 3I Atlas glides on a small ember in the sea of nothing, its rhythm slowing, its memory intact. It does not know that it changed us. It does not know that we named it, that we whispered our wonder into the dark that follows its trail. It simply continues the way gravity continues, the way light forgets to stop shining. Perhaps, in that endless silence, it dreams not of stars, but of the warmth that lingers in every atom that has ever known a sun. Perhaps it is not an object at all, but a thought the universe forgot to erase. And here, on this small blue world, we lie beneath our atmosphere and breathe in the same physics, the same symmetry, the same hunger to persist. We turn our faces upward, not to escape, but to remember that survival is an act of grace, that to keep moving, to keep asking, is itself a kind of life. The traveler fades, the watchers sleep, the question remains. And somewhere between them, between curiosity and eternity, the universe listens to itself, radiant and unbroken. Sweet dreams.